we're going to place that in the machine, and that just induces a failure at that point. What we're going to do is swing the pendulum and impact the sample. Now the pendulum, we know the weight of it and we know the swing, so we know the velocity, and it's calibrated to read in joules. Okay, so 300 joules of energy is our start point, and we're going to measure how much energy our samples can absorb. The difference between the samples is, as I said, they're all 0.6% carbon. The difference between them is that some have been treated. Okay, they've been heat treated. So what we'll have to do to get a representative figure to begin with, we'll have to do a normalised sample that's not been treated. Okay, so we'll do that first, but just to explain the difference between hardness and toughness, which we sort of like associate as being the same thing, don't we really? Yeah. Would you say that's a hard material or a tough material?
Tough material.
It's tough. Yeah, but it's not particularly hard, is it? Yeah. So what about that glass? Is it hard or tough?
Hard.
Hard. Right. Because it's hard, it's also very brittle. Okay. So we can't scratch it. We can with a diamond or whatever. So it's very, very surface hard, but it's made it also very brittle. Okay. Why do we not want our steel to be brittle?
It's dangerous, obviously, going into snap.
Yeah,
you want it to
we're looking at like mechanical components. We don't want them to shatter. Some of the samples are just let cool down slowly, and some of the samples are quenched. Okay, so we took them right out and dumped them in a bucket of freezing cold water. So it cooled it down rapidly. So what properties do you think you get by quenching? What have you done to the steel?
Makes it more tougher.
No, opposite one. Makes it harder, but it also makes it more brittle. Okay.
Yeah.
And the ones that were let cool down slowly become tougher, but they also become surface softer. Okay. So how do we achieve both those properties? What do you think we will do?
Quench first and then cool.
So if we quenched it, we can't. Yeah, we do it twice. We reheat it up to a certain percentage of the original heat. So we would heat it up, quench it, and then reheat it, and then let it cool down slowly. So what we've actually done is permanently altered the structure of that steel. If we put that under the microscope, we took a slice through it, we've actually altered that sort of composite inside. Yeah, it's nickel. Okay. So we'll do two normalised ones.
That group that come to next week doing the same
Yeah,
thing.
right.
Yeah.
All right. Woo! Ooh. Okay. What's that come out of? That's actually chatted there as well, isn't it?
27 that one.
So you can see how brittle it is. Right. This is a Vickers hardness test. Okay. So we made an indent in our steel. You can just see it.
Is that the original one, Jason?
This is the
Yeah, the one
normalised
that we
one.
broke.
Yeah. Now, under the eyepiece, when you look through the eyepiece, you'll see a square indentation. Okay. And it's magnified, and there's a scale in the eyepiece. What we need to do on that square is measure across the diagonals from corner to corner. So we're measuring how big that indentation is. Wind that down now, you'll feel it click.
Need it here with the see if it fits.
Yeah, right, wind it back. Okay, undo that, undo that. Going towards the window, just wind it back. Spin that round. And just slowly bring that down now. Yeah. You got it? You see it? Oh, not too quick. Go back. Go back a bit. Yeah. See what I mean? Right, so we can bring that into line.
I know market. I know
That's about 5.7. What we got first in it? 4.8.
Yeah, so that's your normalised one.
Yeah.
Right, you've got. Right, we'll do one on that. That was your